Okay, this is Vodcast 8.2 on chemical equations, and we are going to talk about our first type of reaction, which is a synthesis reaction. Now, in our chemical reactions, there are 5 basic types of reactions, and we're going to go through each one, and the whole idea here is if you learn the process for each one and the steps for it, okay, then you should be able to do almost all types of reactions. Our first reaction is called a synthesis reaction. Now, this is generally considered the simplest type because the word synthesis simply means to make. Now, in generic form, okay, all you're doing is, in this very simple, you're going to take 2 single elements and they're going to combine to make a new compound. Although a synthesis doesn't always have to be single elements. The easiest single synthesis reaction is when you're taking 2 elements and you're combining them to produce a binary compound. This is the easiest because all you need to do is look at the charges that the elements would produce and then put them together based on their charge. So if I start here with calcium plus sulfur, what I would do is I look at the periodic table and I'd say, okay, what charge does calcium produce? Well, it produces a +2. What charge is sulfur? That's a -2. So calcium plus sulfur is going to give me CaS. And then of course you'd always go through and balance, and you'll find that these balance pretty easily. So if I get copper plus chloride, okay, now this will be interesting because copper can form more than one charge. So you can't really get it wrong because you can choose the charge you want. So if I use a +1 form of copper, then this will be Cu, and chlorine's a -1 charge, so this will be CuCl. Of course, if I do choose that, then I need to balance it. So I have 2 chlorines here. Oops. So I would have to put a 2 out in front of that, and then I'd have to put a 2 there to balance it. Now, if you choose the +2 version of copper, that's going to balance right away into CuCl2. So you kind of get to choose the charge that you want, and you can't be wrong. Okay, so if I go to Ti plus phosphorus, okay, Ti again has multiple charges, and one of its charges happens to be the +3, and I know phosphorus can be -3. So if this is the +3, then this just becomes, oops, I was thinking tip in my head, so that's what I wrote. This becomes TiP. So give this one a shot. What do you think this one would be? Look at your periodic table and find the charges of molybdenum and then write it out. So oxygen is a -2, molybdenum can be a +3. So one of the versions I could have is MO2O3. And then of course I would need to go back and balance it. So this is a correctly written formula, so I would actually have to go back and balance it. Now theoretically you should not have those charges in there. So balancing this, okay, I'm going to have to probably put a 2 in front of that. And so I'm going to have to put a 4 there. And I will have to put a 3 here. Okay, that's just one of the versions. Another version you could actually do is you could write this as MOO3. Okay? So with these synthesis reactions, you're just putting things together. Now, you might come across things with diatomics. And again, you'll just have to pay attention to charge. because iodine, okay, is going to be a -1 charge, aluminum is going to be a +3 charge. So when I put these two together, this has to be Al(I)3. But then, of course, you'll have to go through and balance. And I don't like writing the charges there, so I'm just going to erase those. So looking at this, there's no way I can have an odd number of I2s, so I'm going to probably have to put a 2 here, 2 aluminums, 3 I2s. So those are the simplest types of synthesis reactions. Okay, some somewhat more complex synthesis reactions are going to be when you have metallic oxides and carbon dioxide reacting together. Now, the term metallic oxide, you are going to see more terms like this. It's a generic term. Metallic is simply referring to any metal, and oxide is just oxygen. So this is any metal with oxygen. That's a metal oxide. So a metal oxide is any metal with oxygen. And you're going to react that with carbon dioxide. And the thing about this is they always produce a compound that has a carbonate in it. So here's my first example. I have calcium oxide, there's my metal oxide, plus carbon dioxide. These two are going to combine and give me this CO3, which is a 2- charge, and calcium, which is a 2+. So CaCO3 is my compound. This oxygen basically globs onto that, and that's where your O3 comes from. Okay, here's another one. Na2O plus CO2. Okay, is going to give me Na2CO3. There's my carbonate. See what you can come up with these three. Do these three on your own. One of the things you're going to have to figure out is what are the charges of these. So this Fe here is a +2 Fe. And that's kind of nice because the CO3 is the -2 version of it. So this will be FeCO3. And right now everything's coming out pretty balanced. So again, down here this copper, oxygen's a -2, so this is the +2, so that's copper 2 oxide. So that's going to give me CuCO3. And now I threw this one in here down here. Okay, that's going to be a different charge. Okay, so this iron is going to be a +3 iron. That's going to give me a different carbonate. And so I'm going to have Fe2CO3 3. Okay. So that is a metal oxide with carbon dioxide, and they're always going to produce this carbonate compound. Right? Here's another one. If I have a metal chloride plus oxygen, and here's this generic term again, metal chloride. Metal chloride is, again, any metal with oxygen. Oh, excuse me. Any metal with chloride. And I'm going to react that with oxygen, and that's going to produce this chlorate compound, which is a -1. So here's my first one. Metal chloride, metal chlorine, KCl, plus oxygen. Now, that's going to produce this chlorate, which is a -1, with a calcium. So that's going to produce KClO3. So there's my metal chlorate. Now, this is going to have a little bit more balancing to it, because I have one chlorine, or one potassium, so that's good. One chlorine, so that's good. Oh, I hate when that happens. Okay, so my oxygens are the issue. I have 3 oxygens over here. I only have 2 over here, and they're odd, so chances are I'm going to have to put a 2 in front of that, and so I'll have to put a 3 there, but putting that 2, okay, makes those uneven, so I will have to put a 2 in front of the KCl. So balancing will be a little bit more of a challenge with these, but again, there's actually going to be a pattern that you will see once you get going. So again, my metal chloride, sodium chloride plus oxygen, is going to produce this metal chlorate, and that's just going to be NaClO3. And again, you have the balancing issues. I have 2 oxygens and I have 3 oxygens. So those are not going to balance very well. So I'm going to have to put a 2 here, and a 3 here, and a 2 there. And you can kind of see that these 2 are the same type of deal as far as reactions, and they balance the same. And that's what happens. See if you can convert these or balance these. So the first issue that you'll have is Ba, in this case, is a +2. And remember, ClO is a -1, so I'm probably going to need 2 of those. So my formula is going to be BaClO3, 2. Okay, and now you have a little bit more of a challenge with balancing. Okay. Balancing wise, okay, I have 1 Ba and 1 Ba, so those are okay. I have 2 chlorines, and with this 2, I actually have 2 chlorines, so those are okay. So it's just my oxygens, and I have a total here of 6 oxygens, so if I just put a 3 there, we should be balanced. And then this last one, this Fe is a +3. So this is going to be Fe parentheses ClO3, 3. And then we'll have to balance it. Take a moment and do that. So balancing this one should be 2, 9, 2. Okay, so that's another type of synthesis. Our last type of synthesis reaction is, I'm sorry, the second to the last. I have a metal oxide. Okay, so now we're back to any metal with oxygen again, plus water. Now, any metal plus water produces a base. Now, a base is anything with hydroxide ions in it. So bases will produce these OH minus ions. So if I have Na2 plus H2O, I'm going to get a compound that has hydroxide ions. Okay, well, I need the metal to go with that, which is Na. Na has a plus charge to it. So when I write the formula, I have Na plus 1, OH minus 1. So my compound is going to be Na OH. Then of course we would need to balance, and I have 2 sodium, so put a 2 in front of that. Okay, I have 2 oxygens, so I think those are okay, and I have 2 hydrogens, so that's okay. All right. So let's look at this one. FeO plus H2O. Okay. Again, you're going to have to figure out the charges of these. That Fe is a +2. And this water, that's going to produce that OH minus. So you have an Fe that's a +2 and an OH that's a -1. So this compound is going to be FeOH2. And then of course we would need to balance, and I think we are balanced. Yep, that one actually comes out balanced the way it is. Okay, see if you can do this last one. So you have an Mg, which is a +2. Okay, oxygen -2, Mg +2. And again, you have your OH. So I'm going to get the same deal as I had before, MgOH2. And then, as I look at this and see whether or not it is balanced, I have 1 Mg, 1 Mg, good. 2 oxygens, 2 hydrogens. So we're good. All right, the last synthesis is a metal oxide plus water is going to produce an acid. Now, we've talked about acids. Acids have H+ ions, or hydrogen ions. So a non-metal oxide is a non-metal with oxygen, and acids contain hydrogen. Now, these get a little bit trickier once we get going, so we'll start out with some easy ones. So SO3, that's my non-metal oxide, and obviously water. And what's going to happen here is that water, or that oxygen, is actually just going to glob onto that. And so what hopefully you see is you have SO4. And then I would hope that you would recognize SO4 as the polyatomic ion sulfate, which has a 2- charge. I'm going to put hydrogen with that, which is a +1. So this should be H2SO4. Which kind of works out nicely with that 2 right there. Okay? Again, this oxygen going to glob onto that PO3, and that's going to become PO4 3-. And I'm going to put a hydrogen with that, which is a +1. So what would that formula be? And hopefully you say H3PO4. And now we do have a little bit of a balancing issue here, okay, because my hydrogens are not balanced. So chances are this is an odd number, so I'm going to have to make it even. So I put a 2 there. And I'm going to have to put a 3 there. And put a 2 there. That should be good. Okay. You go and try this last one. Oxygens combined. This one you may have to look up what SiO3's charge is if you didn't know. And then I believe it's a -2. So this comes to H2SO. SiO3 shoot. And then it's balanced as is. So that completes synthesis reactions. So you should be able to complete worksheet 3 in the packet.